Okay, here we're going to find this H prime, H double prime. H double prime okay, here we're going to find H double prime evaluated at 0. So let's jump in and get our derivatives first. H prime of x would be, we need the product rule here. So we have a 1 cosine of x plus x times a negative sine of x. Okay, I'll take one simplification step, cosine x minus x sine x. And then I'll head to my second derivative. Okay, H double prime. We have a minus sine of x for the cosine. We have, now I need the product rule on this second term here. So I'm going to put minus. This minus here comes down. And this will be just a 1 sine of x plus x cosine of x. Okay, and I'll just simplify this a little bit. So we have that. That's the same thing as this. Minus 2 sine x minus x cosine x. And now I'll go ahead and evaluate it. H double prime of 0 equals negative 2 sine of 0 minus 0 cosine 0. That's all 0. Everything is 0. So now we don't really have an interpretation for that second derivative, but we will soon enough. What does it mean? I mean, we know the first derivative represents rate of change of the function with respect to x, but we don't know what the second derivative means, other than that it's the rate of change of the first derivative with respect to x. We know that. Okay, this next one, find the equation of the tangent to f at x equals 0. So let's go ahead. We need to get an equation of a tangent line to this graph. We need the slope of that tangent, and we need the ordered pair. So we can get the ordered pair. F of 0 is actually 0. So this is our ordered pair, 0, 0. We need the slope. Well, we get that from the derivative. Okay, because the derivative will give us the slope of the tangent. And then once we have that, we can write the equation of the tangent. So let's find f prime. It's 1 times the sine of x plus x cosine of x. That's the product rule. Now we want f prime of 0, because that's the point we're interested in. And that's going to be a 0 plus a 0. Okay. So we see that m that we're looking for is actually a 0. There's a lot of zeros in this problem. So now you come back to this. Y minus y1 equals m x minus x1. That is our standard go-to point slope form from geometry that we use. And we'll put in our numbers here. We have a y minus 0 equals 0 times x minus 0. A lot of zeros here. And that's our equation. It's not much, but that's it. Okay. And that's the procedure we use for finding those.